Hey everybody, another example for us to look at, and this here is probably more apropos to a real world scenario. Okay, so assume that the human body temperatures are normally distributed with a mean of 98.19 degrees Fahrenheit and a standard deviation of 0.61 degrees Fahrenheit. So they've given us our mean and our standard deviation. And here they tell us a hospital uses 100.6 degrees Fahrenheit as the lowest temperature considered to be a fever. What percentage of normal healthy persons would be considered to have a fever? And does this percentage suggest that a cutoff of 100.6 is appropriate? So, what they've given us here, and well, the first thing I'm going to do is go ahead and trace out a density curve for me to be able to use. Let me make it a little darker. There we go. And what I have is I have a mu of 98.19. I have sigma of 0.61. And what they give me, okay, they give me a temperature, so that's going to be my x. So this is what I'm looking at. This is my density curve, crooked as it may be. My apologies. Okay, so somewhere down here. This is my mean. This is mu. It's not 0, so I'm going to do some converting. I'm going to use that my conversion formula. But this is what I have. This helps put stuff in perspective for me. And over here somewhere, I don't know really where it falls, but this is just helping me to visualize. This is what I have. Okay. And now I need to be able to determine, okay, where am I shading? Am I shading to the left of this or to the right? Well, sometimes it's not clear from what's given if you're just trying to think of it from a statistical standpoint. What you need to do is just use some reasoning with it. I'm talking about fevers. I'm talking about the minimum temperature of a fever. So I wouldn't be talking about to the left of this. This is normal body temperature, what they're saying, the mean. If I go to the left and I'm compassing even all the way down here to where people were hypothermic instead of hyperthermic. So the area that I'm looking at is right here. So that helps me see what I'm actually trying to find. I'm trying to find a smaller percent of people, but also it lets me know that my graph is showing that I'm reading from the right to the left vertical boundary. I'm going to have to do some switching because again we read from left to the right vertical boundary, but this is what I'm trying to find, this right here. So I need to find a z-score for that, and it's going to be a small percent, so I know that I'm going to end up with having to change the z-score. So I have z equals 100.6 minus 98.19 divided by 0.61. A little calculation. Okay, I end up, this is a large z-score. So if it was positive, what it would this would equate to is like 0.9999, almost 100%. But it's not. I need to use symmetry because I'm going from the right to the left vertical boundary. So the z-score that I'm going to look up is this, z equals a negative 3.95, which corresponds to the same thing on your tables once you get past and you should remember this from earlier chapters, 2 standard deviations away. Once you get to a z-score that's 2, you're starting to get significance. This is very significant. So, but I'm going to show you this on your, let's see, negative z-score. It's a negative 3.5 and lower. This is what you're looking at, 0.0001. So I have 0.0001. and it's wanting a percent. So if I were to move that, what I'm looking at is I'm looking at 0% of the patients is what I'm looking at for this. And so what percentage of normal healthy people would be considered to have a fever? Zero. Does this meaning that that temperature is too high? To I need to lower this temperature down for consideration of a fever. Does this percentage suggest that a cutoff of 100%, 100.6 is appropriate? You could say yes or no. I would say that yes, if you are actually dealing with normal, healthy people, your body temperature can fluctuate. That what you're looking at here is an appropriate temperature, but hospitals may want to err on the side of caution and lower that some, so that way they're ensuring that they're treating everybody. But if you're normal and healthy and you're exercising, working out, and your metabolism's going, then yes, your core temperature can easily be higher than that. Hey, there's a part B to this one, so let's look at part B. And this is where we're going to do some adjusting. Physicians want to select a minimum temperature for requiring further medical tests. What should that temperature be if we only want 5% of healthy people to exceed it? So, meaning they don't want to waste money testing people, so they want to lower the temperature just enough to where they're erring on the side of caution and only testing those people that need it. So you think of this as like flu season. So this is what I have, and my information is still the same. Mu, where's that other piece of paper at? 98, sorry, couldn't find it. 98.19, 0.61, and this is my 98.19. Whoops, 19 right here. It's in the middle. So what they're wanting is they're wanting 5% that exceed it. So if we're thinking about this, again, we're going to need to be to the right. Okay, again, this is what we're looking at. We're wanting some temperature here, X, that represents 5% or 0.0500. That's the area in there. Because it's, even though we look at this and we say 5%, well, 5% would be down here. What we got to do is take into context. We're looking at the mean body temperature right here, and we're talking about fevers. This would be hypothermic. This would be people that are too cold. We're looking at people that are feverish. So that's where the 5% is represented at there. So I need to take this and find a z-score. And this is a common z-score, and it is different than the other ones that you deal with. And what this will be is, once I'll pull it up and I'll look up the actual 0.05. 0.05, that, and that comes down to here. This is a common one. You'll start seeing this in 7 and 8 all the time. Notice the z-score, it's taking out the 3 digits. Trust me, you can have z-scores that are much more refined than what we have in these tables, but a negative 1.645. Is what we have for that. Okay, but I looked up that 0.05, so I need to use symmetry and get the positive value. On a sidebar, this is the z-score. If we looked up this 0.95, if I just went ahead and did the complement of this, the area, if I did the complement of the area, it would correspond to this z-score. So what I'm going to have is I'm going to solve for x, and you should remember the formula. So I have a z-score of 1.645 times 0.61 plus 98.19, and that will give us our x. That will give us the body temperature we need to be able to encapsulate 5% of the population. And type this in. I have a body temperature of 99.19 degrees Fahrenheit. And now allow them to err on the side of caution and only probably get about 5% of healthy population. Alright guys, watch your publisher's videos, critically think and structure your homework, and good luck on your homework in Chapter 6.